Yeah, so let's take a pause here. We have looked at a few datasets. We have looked at how to load them, how to play around with train test splits, how to create sub datasets, how to access a specific index, what are features of a dataset, seen how to store a dataset in an efficient format and then load it from the disk. What else have we seen? Yeah, I think that's about it. Now there are a few other common things, like common methods, right, that are frequently used or accessed when you are using the datasets package or when you're dealing with large scale machine learning, deep learning projects, right? So let's talk about those now. Yeah, so some of these are filter, map and concatenate. Again, you would be familiar with what these terms mean, right? Map, I'm sure everyone who has worked in machine learning would understand what it means. Concatenate is straightforward to understand, but let's look at what we do with these, right? Yeah. Yeah, so as mentioned here, these methods operate on all the samples, on all the splits, right? So let's see, once we take an example, we'll understand. So, and we can use these methods across multiple CPUs to parallelize it, and these are specifically or like generally used when you have large scale data sets, right? So you would want to parallelize on multiple CPUs so that your job gets done faster, right? So let's import the relevant library for that. So we are importing multiprocessing and we are trying to count the number of CPUs, right? In this case, on the machine that I'm running this on, there are 12 CPUs there, right? So we can parallelize across 12 CPUs, okay? So let's look at the filtering method. Yeah, so here's an example, right? That suppose you have a data set and say of reviews, right? And there are some reviews which are very small, right? Or let's look at the translation example also. Maybe there are some translations, some sentences which are very small, just one word, two words. And you might think, okay, these sentences may be noise or these sentences may not really help much in the training. It might do more harm than good, right? And I mean, just you have an intuition for this or you have seen this in the past that certain samples are not useful, right? And you want to filter out those samples. So in this case, I am taking the example that the text should have at least 100 words, otherwise it's not useful for me, right? Suppose that's the assumption that I have. Or I may just want to count, right, the number of samples which have more than 100 words. Yeah. So now before filtering, this is what the dataset dict looks like. It has 25,000 rows in the training set and 25,000 rows in the test set, right? And the reason I'm printing this is because whatever we are going to do now, as I had mentioned, it will apply to both the train split as well as the test split. So we have seen these numbers are easy to remember, 25,000. So we'll now do the filtering, see how to do the filtering and then again check what happens after filtering, right? So let's see. So what we are going to do is that we are taking the threshold as 100 and we want to filter this data set, which is the original data set that we had. And I'm looking at the original data set, that means it contains both the train and test splits. And I'm saying that I only want examples where such that the length of the example, right, or the length of the text of the example. Remember the data set had two fields, label and text. So I'm saying that the length of the text of the data set should be greater than equal to 100 words, right? So you understand what happens with this part of the code, right? Let me see if it's visible on the screen. Yeah, it is. So this part of the code is just sort of splitting the entire text on spaces, right? And then counting the length of that, right? That's what the length function outside will do. And we want this length to be greater than equal to 100 words. Only then we want to take that example, right? So we are taking all examples such that the length of the text of the example is greater than 100 words. So now that's the filtering has been done, right? It's done in parallel across all the samples. So you can imagine that these samples have been split across the 12 CPUs, the condition has been checked and only the matching ones have been kept in the dataset, right? So let's now execute this. Yeah, so now you can see that, oops. Yeah, so now as you can see here, originally we had 25,000 rows. Of course, now we have fewer rows because maybe there were roughly 3,000 samples which had less than 100 words. And similarly in the test set, there were roughly 3,000 samples which had less than 100 words, right? So this is a very important utility which in parallel you can do it for the entire data set across all splits and filter based on specific criteria, right? And you, for your specific use case, you may have to figure out what this filtering criteria is, right? As I said, in this case, it's based on number of words. You might have things like, okay, you don't want any sentence which starts with a the. I'm just cooking up something, or any sentence which has, say, a word from an objectionable word list, right? It should not contain any swear words and so on. So you can add that condition here, and it will filter out the words which do not meet that condition, or only retain those which meet the condition that you have specified, right? So very useful utility to have. The next one is map. This is again one of the most frequently used operations. So now suppose for all the examples in your dataset, right, you want to add the prefix IMDb to it, right? Now this may look like very toyish or childish to do, but there are scenarios where you may want to add, or you may want to remove, say, quotes from all the datasets, right? Or you may want to remove stop words from all the rows in your dataset, right? Because you may feel that that doesn't really matter. So you may want to remove all stop words, or you may want to remove all punctuations and so on, right? And you want to do this across all this splits that you have. So that you can do with the map example. So what I have done here is first define this simple function which takes in one example, right, and takes the text of that example and adds the prefix IMDb to it, right? So the original text is taken, which is, oops, sorry, here, and you are adding the prefix IMDb to it and storing it as the new text. And that's very simple what you're doing here. So you have created a function which takes one example and does the required processing on that example, right? But you don't want to do this sort of iteratively in a loop, especially if you have a very large data set. You may want to use the map function. So let's see how to use the map function. So now you are saying that imdb.dataset map, and you're passing the function which we had just written, right? The function name was add prefix. So you're just adding that function. You're passing that function as an argument. So this function will now be applied to the entire data set in parallel, and once we execute it, the number of rows remains the same. I hope I have a piece of code where, yeah, okay. So now, yeah, let's look at one sample from the data set. And as you can see, the IMDb : string has been added to the text now. And I've just picked up a random example here. You could change the index and try some other index, and you will see the same effect, that the string IMDb has been added to the as a prefix to the original text here, right? Okay. The last is concatenate. This is again a useful feature when you want to concatenate one or more data sets, right? Two or more data sets. So you may have many sentiment analysis data sets. IMDb review is one, maybe something from Rotten Tomatoes, maybe some other Amazon reviews data set and so on. And you may want to concatenate all of these and create a larger data set. And especially in the context of pre-training, right? Different people have released different data sets, and you might want to concatenate all of them and sort of put together and create a larger data set for pre-training, right? So that's a common thing to do. Of course, when you are doing this, that it's important that all the data sets have the same features and the same number of splits, right? And this again makes sense if you have different columns. So one data set has text and label, the other data set has text, label and comments, or text, label and remarks. Then obviously you cannot concatenate. I mean, concatenation makes sense when you have things which are similar and can be actually merged together, right? And of course, also same number of splits, because then the train splits can be merged, the test splits can be merged, and so on, right? So it makes sense why this is required. So now we are going to load different data sets and then try to concatenate that. So we are loading the whole of IMDb dataset, sort of merging the train and test splits and creating one single dataset. I'm also printing the features. Yeah. So I've loaded the IMDb dataset, which contains 50,000 rows now because I have merged the train and test splits. Now similarly, I'm going to load the Rotten Tomatoes dataset. As you can see, the unique identifier here is different. It's something from Cornell and / Rotten Tomatoes, and I'm loading all the splits together. So I have the whole dataset loaded. Let me execute this. So I get a single dataset containing the same features, text and label. I had said that is a prerequisite. So, and the features are text and label, as you can see here. And the features are the same, right? So this has negative and positive class, same as the other data set, and the text is of type string, right? Now we can combine the data sets. So we can say that I want to concatenate these two data sets, and I'm just passing them together as a list, right? So I've just created a list containing both the datasets, and then I'm saying that I want to concatenate these two datasets. So remember, one of the datasets had 50,000 samples. I forgot how many the other one had, 10,000. So now if we concatenate, obviously it will have 60,000 samples, right? So that's what happens now. We have a single dataset. Now we could do further things on this. We can create train test splits using the combined dataset, right? And it internally shuffles the samples before splitting. So we can do that now, right? Now another thing that you might want to do is interleave datasets, right? So what do we mean by that? You may have different datasets for the same task, and the number of samples in the dataset might differ, right? I mean, one dataset, say from the movie domain, may have 10,000 samples. A dataset from the cars review domain may have only 1,000 samples. And now you want to sort of merge these datasets, but also be mindful that you interleave them in the same proportion as the original dataset, right? As the distribution of the original datasets. So IMDb has 50,000 samples and Rotten Tomatoes has 10,000 samples. Now we'll build a new dataset that contains 60% of samples from IMDb and 40% from Rotten Tomatoes, right? So although the original distribution was different, we want to create like a combined dataset such that the proportion of samples there is 60% from IMDb and 40% from Rotten Tomatoes, right? So now we are going to use this function called interleave datasets. Again, we are going to pass the two datasets that we want to sort of merge and interleave, and we are going to say that the first dataset should have 60% and 60% sort of quota, and the second dataset should have 40% quota. Now let's see what happens when we merge it. Yeah. So now as you can see, actually the original dataset, right? When we had merged both the datasets as it is, there were 60,000 samples. But now when we are trying to interleave and merge them, there are only 26,000 samples here, and it makes sense because the Rotten Tomatoes dataset only had 10,000 samples, right? So when I want it to have 40% of the quota, I have to take the entire 10,000 samples, right? And now what remains, if this is 10,000 and I want this to be 40%, then the remaining what I can take from IMDb is only 15,000, because now 15,000 is to 20,000 will be in the range, it will be in the ratio of 60 to 40, right? So once one data set is exhausted, I'll stop the interleaving process, right? So that's what I'm saying here. The default strategy is to stop when first data set is exhausted, right? Any one of the data sets is exhausted. So I ran out of samples. I was trying to sort of merge the data set 60 to 40. So I was taking 3 samples from IMDb, 2 samples from Rotten Tomatoes, and I was doing this repeatedly. But at some point I ran out of samples from Rotten Tomatoes because it only had 10,000 samples. So at that point I will stop. So at that point, because I was taking in 3:2 ratio, I'll have 15,000 samples from the IMDb dataset and 10,000 samples from the Rotten Tomatoes dataset approximately, and hence you have this roughly close to 25,000 samples in the final dataset that has got created, right? Okay. There are other stopping strategies, so you can look at those. Concept that I want to cover is that of an iterable dataset, which sort of returns, it's for on-the-fly loading, right? Let's see what I mean by that. So suppose you have a very large dataset, right, and it's hundreds of GB, and you don't want to sort of write it to a local disk or sort of get the full download done and then sort of load it from the local disk, right? You just want to use it on the fly, right? Stream the dataset in some sense, right? So that you can do. So as you can see here, now the load dataset method, I'm using the IMDb dataset. I'm saying I just want the train split, but I'm just asking it to stream the dataset. That means it will just load one instance at a time, right? It will not download the entire dataset, but just stream it one sample at a time. Yeah. So now when I execute it, it creates an iterable dataset, and now I can sort of start iterating over the samples in this dataset, right? Yeah, so I can do this from example in the IMDb dataset, print an example, so it will keep fetching on demand, right? So I've just fetched one example and done a break here because of course I don't want to print the entire dataset. And the methods like map, filter, etc. will work on the fly, right? I mean, so when you had the dataset on the disk, it made sense that when you're doing a map or filter, it's sort of applying to the entire dataset. But right now you don't have the entire dataset, right? But you can still use the map and filter, and as you're fetching the examples, the map and filter will work on the fly, right? So that's the cool part about this. So I think that's all I had, and let's see, okay, there's a demo for this, And yeah, so as you can see that on the fly I'm able to do the map. As I'm fetching the example, the map is operating on it and it's adding the prefix IMDb in this case, right? So yeah, that's all I had, and here are a few questions for you to think about and explore. Can we load a dataset directly from external links, right? So we loaded it from Hugging Face, we loaded it from local disk. Now can I load it from some external link, right? So there's some other repository where a dataset is. Can I use the dataset module to load it? Please try it out. And can we load a dataset from zipped files directly, right? Because sometimes you have to zip it because otherwise the size of the dataset is too large. So now how do you load it from a zipped file efficiently, right? So please try out these things as exercises. Yeah, so please try out these things as exercises. I'll stop here now and I'll see you in the next class. Thank you.